So in today's lesson, we're going to be looking at finding limits at infinity algebraically. So to do that, we're going to need to look at a few things to start. Just a little review of end behavior. So if we start with a couple of examples, for example, if I have a function f of x equals 3x to the third plus 7x plus 2, hopefully we remember that when we're looking at end behavior, in this case, the leading coefficient tells us what's happening to the right. In this case, because it's positive, a positive 3, that means the right side is going to be going up. If it was a negative value, the right side would be going down. And then the exponent tells us the left side. And in this case, because it's odd, it's going down. So another example might be negative 2x to the fourth power plus 7x squared plus 2x plus 10. Again, all we care about is the leading coefficient and the leading exponent. So in this case, a negative 2 means that to the right, this graph is going down. And to the left, because it's even, it's the same, so also going down. Again, at the middle, we don't know what's happening in the middle, but that tells us the end behavior. And that's going to let us look at limits as x approaches positive or negative infinity. And the other type of end behavior we have is horizontal asymptotes. So in that case, we have the three cases when we're looking at the degree of the numerator and the denominator. So if the numerator has a larger degree, then it's what's called a slant asymptote. So graphically, we would have something with a slant asymptote, which means that the graph, again, might be doing different things. So what we'll have to do is we'll have to test at positive infinity or negative infinity, large negative or positive numbers, to decide if the graph is going up or going down. So your answer in that case is either going to be positive infinity, like in this case, or negative infinity in this case. Second is when the denominator is a larger degree. In that case, the horizontal asymptote is y equals 0. And then finally, if they are the same, that's when we look at the horizontal asymptote being the ratio of the leading coefficients, a divided by b. And then we'll have one special example where there's actually two horizontal asymptotes, but that'll come later in the last example. So looking at the first example, we're looking here, we have this function, just a polynomial function. So first what we want to do is we want to look at end behavior of this guy and decide what's happening at negative infinity. So again, we look at the leading coefficient and the highest degree. In this case, the leading coefficient being negative 2 says that to the right it goes down, and then a odd degree means the left side does the opposite, which would be going up. So as x approaches negative infinity, we would be going up. So our answer is going to be positive infinity. As my graph, again, let's look at what this happens on the graph. Again, the end behavior this way is up. The end behavior down there is down. Don't know what's happening in the middle. It does not matter, because we're looking at as x goes towards negative infinity, what does the graph do? The graph goes towards positive infinity. So that's how we got that answer. All right, pause the video, work on example B. Okay, I'll assume that you have finished, and here is the answer for there. Again, we're looking at end behavior. In this case, we have a positive leading coefficient, so the right side goes up, an even degree, so the left side does the same. Graphically, again, left side is up, right side is up, middle is whatever. And this time they're looking at it as x goes towards negative infinity. What does our graph do? Our graph goes up towards positive infinity, which is how we got that answer. All right, moving on to example 2. This time we have some rational functions. So we need to look at those 3 scenarios for our horizontal asymptote, slant asymptote, whatever that might be. So we look at the degrees, in this case 4th degree on top and bottom, which means that we have a horizontal asymptote at y equals 3/2. So graphically, we have a horizontal asymptote at 1.5. So whether the graph approaches from the bottom or the top, it does not matter. And it does not matter which direction, positive infinity or negative infinity, they both approach 3/2. So in this case, the limit is 3/2. Okay, moving on to example B, a little bit different because we don't have this in terms of a rational function, but we can do that pretty easily. So this guy needs a 5x on top and bottom. So when I make this simplified, I end up with 3 plus 35x over 25x squared. So looking at the leading coefficients, the degrees, in this case the degree of the top is a 1, the degree of the bottom is a 2. So that tells me that there's a horizontal asymptote at y equals 0. Again, graphically, we have horizontal asymptote at y equals 0. So the graph, again, don't know if it's from the top or the bottom. It does not matter because as x goes towards negative infinity, where does our graph get closer to? It gets closer and closer to 0. So if you'll notice, whenever we have a horizontal asymptote, the horizontal asymptote at infinity, positive infinity or negative infinity, is whatever that horizontal asymptote is. In the first case, 3/2. In the second case, the horizontal asymptote was 0, so the answer is 0. All right, pause the video here. Move on to example C and D. All right, moving on. You can see in example C, trying to trick you here with example C by putting them in different orders. The degree on top is a 3, the degree on bottom is a 4, so the degree on bottom is higher in the numerator, so that makes the horizontal asymptote 0, which makes the limit 0 in both directions, but in this case they're looking at negative infinity. Example D, when we simplify this to a rational function, we end up with an x squared on top and an x on bottom, which would be a slant asymptote. So what we need to do is we need to test a large positive value because we're going towards positive infinity. We're going to test with a large positive value, and a 4 plus something squared is positive, and 4 times something positive is still positive. That's how I got positive over positive. So my answer is positive infinity. So graphically, with a slant asymptote, we don't know if that's going up towards positive infinity or down towards negative infinity. We don't know the answer to that. So that's why we had to test. It was going to be one or the other with a slant asymptote. And in this case, it turned out to be positive infinity. All right, finally, example 3. In example 3, we have this case where we have this square root. So before we get into all of this, graphically what this is going to look like, this is that example where we're going to have 2 horizontal asymptotes. We're going to have a horizontal asymptote at a positive and a negative value. So it's going to look something like this. It's going to be the same value, but it's going to be there. So it might look something, the graph may look something like this, where in one direction it gets closer to a negative value, and in the other direction it's closer to the positive value. So just to understand that. So what we're going to do is we're going to look at, just again, we only look at the leading coefficients, just like in the beginning. And what we're going to do is we're going to say that this limit is very similar to the limit as x approaches positive infinity, and we're only going to look at these two. So 8x to the 4th, and what we're going to do is we're going to take the square root of this. Well, the square root of 4 is 2. and the square root of x to the 8th is x to the 4th. So in this case, we have a x to the 4th over x to the 4th, same degree, essentially. So we look at leading coefficients. So the horizontal asymptote in this case is going to be 8 divided by 2, which is 4. But like I said at the beginning, it's either going to be positive or negative. So to determine that, we need to test. So we're going to test the original function, and because it's going to positive infinity, we're going to test the original with a positive value to determine if it's going to be positive or negative 4. So when we plug in a positive value here, a positive number to the 4th power is positive, times 8 is still positive. And in the bottom, a positive number to the 8th power is still positive, times 4 is still positive, and the square root is still positive. And positive divided by positive gives me positive. So the answer is positive 4. So that would be like this side over here. It's not always going to be positive to the positive, but just test every time. All right, go ahead and pause your video. Move on to example B. All right, example B, same idea. We're looking at the leading coefficients. So in this case, the square root of 20 is 2 root 5 x to the 3rd over 4x cubed. So again, same degree, which means leading coefficients, which gives me either positive or negative root 5 over 2. And because we're going to negative infinity, we test with a negative value. The top, when we raise anything to the 6th power, is going to be positive. Times 20 is still positive. Square root is positive. And in the bottom, a negative value to the 3rd power is still negative. Times 4 is still negative. So positive divided by negative gives me negative, which is why it's going to be negative root 5 over 2.